Hi, this video I'm going to go through building a class, and it's going to have some other features in it also. So let's go ahead and get started. What I'm going to do is go through a document that I have here. This is actually part of a book, and I'm going to go through and talk about how this is going to be set up. Let me make this a little bit bigger for you here. So a very common, turn this off. There we go. So a very common example to show the details of implementing a user-defined class is to construct a class to implement the abstract data type fraction. Already seen that Python provides a number of numeric classes for our use. There are times, however, that it would be most appropriate to be able to create data objects that look like fractions. A fraction such as 3/5 consists of two parts. The top value, known as the numerator, can be any integer. The bottom value, called the denominator, can be any integer greater than 0. Negative fractions have a negative numerator. We're not going to mess with negative stuff on here. So, although it is possible to create a floating point approximation for any fraction, in this case, we would like to represent the fraction as an exact value. So instead of taking 3/5 and dividing 5 into 3, getting 0.6, we want it to be displayed as 3/5. Okay. The operations for the fraction type will allow a fraction data object to behave like any other numeric value. We need to be able to add, subtract, multiply, and divide fractions. We also want to be able to show fractions using the standard slash form, for example, 3/5. In addition, all fraction methods should return results in their lowest terms so that no matter what computation is performed, we always end up with the most common form. In Python, we define a new class by providing a name and a set of method definitions that are syntactically similar to function definitions. For example, we have a class fraction, and we put in our methods in here. Actually, we'll also have our attributes, which are going to be the numerator and the denominator. So that provides the framework for us to define the methods. The first method that all classes should have, word left out there, is the constructor. The constructor defines the way in which data objects are created. To create a fraction object, we will need to provide two pieces of data, the numerator and the denominator. In Python, the constructor method is always called init. It has two underscores before it, two underscores after it. That's shown here. It's also called the initializer. A lot of other languages like Java, it is called a constructor, but Python changed that a little bit. So here's our class fraction to start with. We have our method, our init. We pass in self, top, and bottom. We set self num equal to top and self den equal to bottom. Notice the formal parameter list contains three items: self, top, bottom. Self is a special parameter that will always be used as a reference back to the object itself. It must always be the first formal parameter. However, it will never be given an actual parameter value upon invocation. As described earlier, fractions require two pieces of state data, the numerator and the denominator. The notation self.num is the constructor defines the fraction object to have an internal data object called num, as part of its state. Likewise, self.den creates the denominator. The values of the two formal parameters are initially assigned to the state, allowing the new fraction object to know its starting value. So the state means what is the value at this particular state and time. Okay? So when we pass in top and bottom, that sets the numerator and denominator to a value at a particular state, particular time of the running of the program. So to create an instance of the fraction class, we must invoke the constructor. This happens by using the name of the class and passing actual values for the necessary state. Note that we never directly invoke init. For example, my fraction equals fraction 3, 5. Creates an object called my fraction representing the fraction 3/5 or 3/5. Okay, so I'm going to stop with this, and we're going to go ahead and start working on this a little bit and putting this together piece at a time. So And pull up Python. I've already got it started here. And then I'm going to open up a new file. And we're going to go ahead and get started on creating this. So first thing we want to do is create the class and then get the init set up. So we're going to have class fraction. Most of the time, a class name starts with an uppercase letter to distinguish it kind of from the lowercase variables and object names. Okay, so we're going to do our def, underline, underline, init, underline, underline, and then we have self, top, and bottom. So then in here we're going to do self.num equals top and self.den or den equals bottom. Okay. So that sets up our init on here. Now I'm just going to go ahead and put some code in here, and then later on we'll create a separate file, separate program to run this. But what I can do here is I can do, like I had in here, I can do sorry, wrong thing. Get this straightened out here. I can do fraction with a lowercase f to represent the object equals fraction with an uppercase f to represent the class, and then put in the values there. Now we have fraction. Now if I print fraction, it's not going to give us what we think it's going to. Let's go ahead and save this. And I'll have to navigate to where I want to put this on my external drive here. And I'm going to save this as fraction test.py. Okay, so now we can run it. And what we get here is this right here. What this is that it's printing out where it's located in memory. Because fraction is an object, print can't print out what's inside the object. All it can do is print out what it has from fraction, which is the location of memory. Okay? And then that location of memory has top and bottom in there. So what we're going to have to do is we'll have to put something else in here to be able to do that. So let's go ahead and continue on with our problem here. So the next thing we need to do is implement the behavior that the abstract data type requires. To begin, consider what happens when we try to print a fraction object, which I just did there, and we got something similar to what it has here. The fraction object, my underline f, does not know how to respond to this request to print. The print function requires that the object convert itself into a string so that the string can be written to the output. The only choice my f has is to show the actual reference that is stored in the variable, the address itself. This is not what we want. So in Python, all classes have a set of standard methods that are provided but may not work properly. One of these is underline, underline, str, underline, underline, is the method to convert an object into a string. The default implementation for this method is to return the instance address string as we have already seen. Excuse me. What we need to do is provide a better implementation for this method. We will say that this implementation overrides the previous one, or that it redefines the method's behavior. To do this, we simply define a method with the name underline, underline, str, underline, underline, and give it a new implementation as shown in listing 1.4, which you don't have. I'm going to show you, it's down here. This definition does not need any other information except the special parameter self. In turn, the method will build a string representation by converting each piece of internal state data to a string and then placing a slash character in between the strings using string concatenation. The resulting string will be returned anytime a fraction object is asked to convert itself to a string. Notice the various ways that this function is used. Okay, so let's go ahead and add this one in and see if it changes any. So up in here, we're going to go ahead and create this. We're going to do def, underline, underline, str, underline, underline, self. And then we're going to return str of self.num plus the string / plus str self.den. Let's see what happens when we run this one now with this print that we have down here. And we get to 3/5. So what actually happens here is that when we call print, it invokes or calls the underline, underline, str, underline, underline, which is to convert the stuff into strings and all that, whatever's in here. Okay? Since it couldn't do that with the fraction, we got, let me move this over here. So you can see both of these. We got this address here because that's what was in fraction. So now what we're doing is we're overriding the str with our version. And our version says to take self.num, convert it into a string, add the slash onto it, and then convert the den into a string, and then return that value back, which comes back into print, which then prints this stuff right here, which is this 3/5. Okay? Hope all that makes sense for you. So let's continue on here. And then they had a little example there, which we did. I don't do it in the shell. I'm doing it in a file, so I can save it and redo it without having to retype stuff in all the time. So we can override many other methods in our new fraction class. Some of the most important of these are the basic arithmetic operations. We would like to be able to create two fraction objects and then add them together using the standard plus notation. So at this point, and so we're going to go ahead and do this in our program here so you can see what I'm talking about here. Okay, so I've got one fraction there. I'm going to do another fraction here. Let's change this here to do it F1 and F2. So F2 is going to be equal to, let's do fraction 1, 4. Okay, so we're going to add 1/3, or 3/5, and 1/4. Okay, that's what we want to do. So we want to do a print here. I'm going to do it here. A little thing on the front here. Okay, so that's what we want to be able to do. We want to take two fractions and add them together. So let's go ahead and run this. And we get a crash on this. And what it's saying here is unsupported operand type for plus, fraction and fraction. So it's saying it doesn't know what to do with this. It can't take two fractions. It can add integers, it can add real numbers, it can concatenate strings, but it can't do anything with two objects. So we've got to figure out how we're going to do that. So that's what all this is up in here. Okay. So if you if you look closely at the error, you see that the problem is that the plus operator does not understand the fraction operands. It can fix this, or we can fix this by providing the fraction class with a method that overrides the addition method. In Python, this method is called underline, underline, add, underline, underline. Okay, similar to the str. So when we do a plus, it actually runs this add method that's in Python. It requires two parameters. The first, self, is always needed, and the second represents the other operand in the expression. So if we do F1, underline, underline, add, underline, underline, F2, this would ask the fraction object F1 to add the fraction object F2 to itself. This can be written in the standard notation F1 plus F2. Now what I'm going to show you here is how this works. We could actually, I'm going to do it right here and then it'll crash again on me, but right here I could do x equals 5 and y equals 6. And then I can tell it to print x plus y. Okay? Or I could tell it to do it this way. Y dot underline, underline, add, underline, underline, x. Okay? We'll run this. It's still going to crash on us on the last print statement, but it'll run this one here. And there we get the 11. The 5 plus the 6 is the 11. Because instead of using the plus, we use the actual method name to do this. And this is the format for that. So what we're going to do here, get my document back. What we're going to do here is we're going to override the add method and have it do something different. So two fractions must have the same denominator to be added. The easiest way to make sure they have the same denominator is to simply use the product of the two denominators as a common denominator, so that A over B plus C over D is the same thing as AD over BD plus CB over BD, which is the same thing as AD plus CB over BD. Okay? So hopefully you remember all this from when you did fractions back in elementary school. The implementation is again is shown in figure, but it's right down here below. The addition function returns a new fraction object with the numerator and denominator of the sum. We can use this method by writing. We have def add, then we pass in self and the other fraction. So we have our new numerator is equal to self numerator times other fraction dot denominator plus self denominator times other fraction dot numerator. And then our new denominator is our self denominator times our other fraction denominator. And then we return fraction, so we want to return a fraction, new numerator and new denominator. Okay, so we're going to test this out. Bring back my program here. Move this over out of my way. So I'm going to change all this in here. We're going to do F1 is going to be 1/4. And F2 is going to be 1/2. Okay, so we can't do that directly. What we need to do is have common denominators. So our common denominator is going to be 8. So to do that, then 1/4 would be 2/8, and 1/2 would be 4/8. Okay. So I'm going to take this stuff out of here because we're not doing that now. And we need to go ahead and create our class here, or our method in our class. So def, underline, underline, add, underline, underline. And again, we're going to pass in self and then other. I'm going to cut it down. They do other fraction. I'm just going to do other to make it a little bit simpler here. Okay. So our new numerator is going to be equal to our self dot numerator times our other dot denominator plus, and I think I got to put a backslash on here to continue. Yep, to continue the next line. Self dot denominator times other dot numerator. Okay, and then our new denominator is going to be equal to our self dot denominator times our other dot denominator. then we just want to return a fraction object of our new numerator and our new denominator. Okay. So then what we want to do is we want to go ahead and keep the same print statement to print out F1 plus F2. So we'll run this one now. And there's our F1 plus F2 is equal to 6/8, okay, which is what I said it was going to be. The 2/8 plus the 4/8 would be 6/8. Okay, so let's continue on here with this. The addition method works as we desire, but one thing could be better. Note that 6/8 is the correct result. 1/4 plus, whoops, that got left out of there, put that in there, 1/2. But that is not in the lowest terms representation. The best representation would be 3/4. In order to be sure that our results are always in the lowest terms, we need a helper function that knows how to reduce fractions. This function will need to look for the greatest common divisor, or GCD. We can then divide the numerator and the denominator by the GCD. The result will be reduced to lowest terms. Okay, so the best known algorithm for finding a greatest common divisor is Euclid's algorithm. Euclid's algorithm states that the greatest common divisor of two integers, m and n, is n if n divides m evenly. Okay, so however, if n does not divide m evenly, then the answer is the greatest common divisor of n and the remainder of m divided by n. We will simply provide an interactive implementation here. Note that this implementation of the GCD algorithm only works when the denominator is positive. Okay? So you need to make sure of that when you're doing this. This is acceptable for our fraction class because we have said that a negative fraction will be represented by a negative numerator. Okay, so now one little thing on here, this is what we're going to put in here. In the book, if you're using the book for the class that I'm teaching, that this is going with, they create this outside the class, okay, and then they call it that way. I'm putting this inside the class as a helper for the class. So I'm having this self in here so it can be part of the class. The book doesn't have that; it does it a little bit different. So I have my ways of doing things, and sometimes they don't match up with the way the book does something. Okay, so I'm going to put this up here under the str. Kind of keep it in the same order or something. I don't know however, I just want to do this. So DEF, GCD, we have self, then we're going to do M and N. Okay. I personally wouldn't do the M and N, but I don't want to go ahead and change all this around now, so I'm going to leave it like this. So while M mod, which is a percent symbol, N, does not equal 0, so, and everybody remembers what this is. This is going to take this. We'll take m divided by n and return the remainder. So while that does not equal 0, we're going to go in here and do this. Old m is going to be equal to m. Old n is going to be equal to n. M is going to be equal to old n, and n is going to be equal to old m mod old n. And then once the while loop gets done, we're going to return n. Okay. So what I want to do now is kind of go through with you how this works. So I'm going to move this over here. And I'm going to bring this over here so we can see these side by side here. Okay, so let's say we have, let's do the 6/8. Okay. So we pass in m and n. So m is going to be equal to 6. Let's see. I think m is the is the denominator. So we're going to try it that way because I think that would be right there. So m is going to be equal to 8, n is going to be equal to 6. Okay, while m mod n, so m is 8, n is 6. If we do that, it has a remainder. Okay, so it's not equal to 0. So then we're going to set old, I'm going to do it this way, old m is going to be equal to m, which is 8. Old n is going to be equal to 6, which is the n there. And then our m is going to be equal to old n, which is 6. And our n is going to be equal to the old m, which is the 8, mod old n. Okay, so 8 divided by 6 is 1 with a remainder of 2. Okay, then we go back up to the top. Well, while m mod n does not equal 0, m mod n does equal 0. 6 divided by 2 is 3 with a remainder of 0, so it drops out and it returns n. So our greatest common divisor is 2, and so we take our fraction 6/8, we divide the 6 divided by 2 equals 3, and our 8 divided by 2 equals 4, and that's where we have our fraction now 3/4. Okay, so hopefully everybody was able to follow along with that. Take this down a little bit so it'll fit on the screen better here, on how this all worked here. Okay, so now that we got that worked out in there, what we would do then is, let me go ahead and pull this back over and we'll go through this stuff and then. So now we can use this function to help reduce, it actually is a method in the class because we pulled it in, to help it reduce any fraction. To put a fraction in lowest terms, we will divide the numerator and the denominator by their greatest common divisor. So for the fraction 6/8, the greatest common divisor is 2. Dividing the top and the bottom by 2 creates a new fraction 3/4. Okay, so this kind of shows you what it's going to work like on that. So our fraction object now has two very useful methods and looks like figure 1/6, which we're putting together here. An additional group of methods that we need to include. Well, one thing here that we haven't put in how to use that greatest common divisor yet, so that we'll put that in here in a little bit. But so an additional group of methods that we need to include in our example fraction class will allow two fractions to compare themselves to one another. Assume we have two fraction objects, f1 and f2. f1 equal f2 will only be true if they are references to the same object. Two different objects with the same numerators and denominators would not be equal under this implementation. This is called shallow equality. It's looking at the references or the addresses in memory, not the values in the object. We can create different equality by the same value, not the same reference, by overriding the underline EQ underline method. So the underline EQ underline method is another standard method available in any class. So when you do equal, this right here, okay, do the equal, it's calling this method that's in Python. So we're going to override that. So the method is available. Let's see, the equal method compares two objects and returns true if their values are the same, false otherwise. So in the fraction class, we can implement the equal method by, again, putting the two fractions in common terms and then comparing the numerators. It is important to note that there are other relational operators that can be overridden. For example, the less than or equal, LE method, provides this less than or equal functionality. Okay, so we're going to go ahead and add this in, and we'll add in the part that we need to to use that greatest common divisor. So let's put in our get this going here, our equal one first. So we're going to put that in underneath our add here. So we're going to have our DEF, underline, underline, EQ, underline, underline, and then self and other. Okay. Right place here. There we go. So our first, there we go. First numerator is going to be equal to self dot num times other dot den. And our second, because we what we need to do is have common denominators, and then we compare the numerators. Okay, so that's what we're doing here. So our second numerator is going to be equal to other dot numerator times self dot denominator. So we're taking the numerator, multiplying it times the other fraction's denominator, and then taking the other numerator and multiplying it times the original, the first denominator. That gives us our two numerators that are using common denominators, and then we can compare those and return that value. So we're going to return first numerator equal second numerator. Okay. So what I'm going to do here is I'm going to remove all of this stuff down here out of this, and I'm going to save this. Okay. Then I'm going to open up a new window, new file. It used to be called window, and then they changed it to file when they came out with version 3. And we're going to create a main function in here that's going to test this for us. Now, two ways that I can import this. I can do an import fraction, which will import the fraction class that I just saved here. But the problem with doing that is that every time I want to create an object, I have to put fraction dot fraction on it. So if I do this instead, from fraction import fraction, it just imports this one class. Well, it's the only class I have in there, so it makes it easier doing it this way. Okay, so now we're going to do our main. We're going to create a bunch of objects on here. We're going to have a 1/4, and then we're going to have fraction 2, and this one's going to be 1/2. Fraction 3. This one's going to be 3/4. Fraction 4. Whoops. And the last one's going to be 6/8. Okay. So now what we're going to do, oh, I'm still working in here. There we go. We're going to take fraction 1, print fraction 1. Then we're going to print fraction 1 plus fraction 2. Okay. Get my notes down here so I get everything in here that I want to do. Then we're going to print fraction 1 equals fraction 2. Then we're going to print fraction 3 equals fraction 4. Okay, now I'm going to go ahead and put labels on all these. so that we can see what these are. Okay, and then the last one, I'm just going to copy and paste this down there and then change it to 3 and 4. Okay, and then I'll call main. Okay, I'm going to save this. Now I saved this as fraction test here, so I'm going to have to change the name of that when I get out of this. So I'm going to go ahead and save this as test fraction.py. And then I got to close everything in order to change the name on that. So just to show you a little bit of stuff here. Okay. Let me go to my directory here. Okay, so I'm going to start up Python again, and I happen to have it on my start menu here. And then I'll have to navigate. Let's just get started. There we go. Have to navigate. My phone going off if you happen to hear that. To where I have this. Okay, so I don't need to open my fraction class. What I need to open is my test fraction, which is this one here. And then I'm going to go ahead and run this and see if I got any errors in here. Nope, doesn't look like it. So fraction 1 is 1/4. Give it a second. My power cord sometimes doesn't, there we go, doesn't charge, so I had to jiggle it. So I got it going now. So fraction 1 is 1/4. Fraction 1 plus fraction 2 is 6/8. Didn't reduce it down. Notice that. It reduces it down when it brings it in. Okay. Fraction 1 equal. Fraction 2 is false. And if you remember from what they were, fraction 1 was 1/4. Fraction 2 is 1/2. Those are not equal. And then fraction 3 equal. Fraction 4 is true. And bring that back up again. 3/4 and 6/8 is true when this is reduced down. So it all works. Okay. Now, go up to fraction class. Here we go. So what you could do with this now is expand this by adding a subtract and multiply method. You can always look those up on the internet, how to subtract fractions and how to multiply fractions. You could do division, but you have to be careful with that because this is not set up for that. To where if you're dividing two, remember on division, you flip one of them, okay? And so if you get into negatives or something, it could mess things up on your own net. So you have to be careful with that one. And then the same thing, then we did the equal. You could do the less than or equal, greater than or equal, greater than, and not equal on all these also. So, but this gives you an idea of how creating classes and that. The other thing we could have done in here, we could have put in our accessors and mutators for the top and bottom, or for the numerator and denominator on here. So some other things that could be done with this. So I hope you got some information out of this that are helpful for you, and that you keep watching my videos. Bye.